I'm Philip, and I will introduce to you a use case for AI optimization here at BSH in our systems engineering approach. So BSH appliances are complex distributed systems. So we have embedded hardware, we have embedded software, we have cloud software with our Home Connect cloud, and we have also app software with our Home Connect app. And usually it's industry standard that for developing such distributed complex systems that you follow a systems engineering approach. The most famous one of those is the V model. Basically, what you do in the V model, you have different layers of system definition all the way down to the implementation of the system. And you follow up every layer of that with an individual verification or validation layer. And you have iterative loops between those layers. And if you look a bit closely into the V model, you will realize that almost all of the use cases that we have there, the steps, the tasks we're doing, have to do with the generation of language artifacts. So a requirement is a language artifact, a piece of source code is a language artifact, a test case is a piece of language artifact. And as we all know, a couple of years ago, there was a revolution with the large language models with generating language artifacts. So we started 2 years ago to say, how can we apply this large language model revolution to our systems engineering process to increase the efficiency of the process, and in doing so, reduce our time to market of our product development. We did so in a funding project. So I'm demonstrating here today one part of a funding project that is funded by the Bavarian state via the BayTP Plus funding program. All right, so what are we doing in this funding project? Very quickly, before we go into one of those, we are looking first in requirements management, and I will elucidate about that a bit more closely in the next slides. Basically, everything there we're doing is about requirements, checking the quality of requirements, searching for similar requirements, generating requirements, and stuff like that. Then we have software development, of course. So this is a project from our product development side, not from our IT side. So this is mostly about generating embedded source code or embedded source code in software development. So it's about generating source code, generating unit tests, generating API documentation and stuff like that. But also, for example, we have our user interfaces in our appliances that are translated into 30 plus languages. So there also a question is, can we use large language models to kind of automate this translation at least a bit? And also here we look into knowledge-based generation. So can we use AI to generate a knowledge base of company knowledge to make the onboarding, for example, of new engineers a bit more efficient? And then we have the topic of validation and verification. Of course, every requirement that leads into an implementation needs to then checked against the requirement in testing. So this is about, can we use large language models to generate test scenarios out of requirements? Can we then, out of those scenarios, generate test code or test cases? And also in the end, if we have an error, can we do, for example, log file analysis with large language models, or have a large language model check the severity of an error, for example? And then overarching, of course, with large language models, we always have the topic of hallucinations, of AI trust. So we cannot have the large language model invent a regulation that we need to fulfill. Everything needs to be double checked. So the question is, how do we handle that? And also, do we have some efficiency gains in between those steps? So when, for example, we test an implementation against a requirement, is this running efficiently, this interface between the different steps, or can we use large language models to, and for example, chatbots, multi-agent systems to make this also more efficient? What do we want to gain by that? I mentioned it before a bit. The overall goal is to increase our quality and increase our efficiency, to have a quicker time to market of our innovations. So we're looking at what are the individual tasks in our systems engineering process that are time intensive and that are recurring. So how can we identify those and automate them? And then also, how do we increase the quality of all of our work streams, of all of our systems engineering steps? So for example, can we have fewer errors in our requirements? Can we have a more complete system definition with our requirements? Can we produce better code quality and code documentation? and also can we increase our test coverage with large language models. And I also mentioned this before, can we create a system where we can onboard engineers more quickly through LLM support. But today we will focus on the first part of that, one of the driest part, I'm sorry about that. This is the requirements management or requirements engineering. This is where what a home appliance should do is defined. So we have different levels of requirements, starting with L0 down to L4 or 5, I think, that define essentially what a product is in development. And these requirements, probably most of you are more coming from the software development side, where you use user stories. In product development, you usually use requirements that have a very strict syntax on how they should look like. So you can see the syntax, the template here on the right side. So you have, for example, a precondition. If something happens, the system, this is the system that should fulfill the requirement, shall is usually the keyword for requirements. And then you have some kind of tasks that the system should do in a specific case. And we have this very strict syntax here, so that if you write a requirement, every other engineer can comprehend it. So you're aiming for intersubjective comprehensibility. So when a system engineer writes a requirement, he writes it, and then it's usually afterwards reviewed by other systems engineers or requirements engineers. So this is a task that is really done, and the first step in this task is checking the syntax. So is the right nomenclature used? Are the right keywords used? Is it following our syntax template? Are the preconditions correct? Are there spelling errors in the requirement? And this is something that is quite easy to automate via large language models, and this is basically the first use case that we have tried to fulfill. So here's a short demo of doing that with just a quick web front end. So this is a faked requirement that is used there. And we are running a syntax check on this fake requirement. Takes a bit of time, and when it's finished, I will pause it so you can see the results. So it's checking against a lot of these syntax rules that we have formulated. And here you can see what the large language model is saying, that this requirement is formulated in a passive voice, which is not correct. So usually a requirement needs to be formulated in an active voice. So if something happens, the system shall do something. So in this case, the requirement from a syntax perspective is wrong. And the large language model is giving a very detailed explanation on what is wrong here. Challenges in this is actually creating a data set and creating prompts for the large language model to cover all the possible errors that you could do when writing requirements. So we have collected a very large data set of requirements. We annotated this manually with ground truth labels. And then when we fine-tune our prompts or evaluate different models, we run this data set against our expected results and see then how our system, our prompt, our large language models perform. All right, then this is the next slide. We not only check for syntax, right? So we also want to check, is the quality of what's written in the requirement okay? This is basically also more important. And here there's some industry standard criteria that you want to check for a requirement. So is it clearly formulated? Is it atomic? So you only want to have one topic in a requirement, not a combination of multiple requirements. Is it complete? Does it have internal consistency? So is there maybe some inconsistencies where one part of the requirement says one thing and the other says something different? Is it unambiguous? So we don't want anything that could be interpreted in two different ways in a requirement. A requirement needs to be always verified. I hark back to the V model. So every requirement leads into an implementation that needs to then be verified against the requirement. So the requirement needs to be verifiable. And also a requirement should be unspecific in terms of implementation. So the requirement should not say how something needs to be implemented, only what needs to be implemented. So there's two components here. The first batch of criteria you can check just purely with the requirement text. So what you see here on this slide is something that you can check with purely the one requirement. But we also have a requirement quality criteria that you need to check against the entire system. So is your requirement consistent with all the other requirements in the system? is the whole set of requirements in that case then correct? Can you trace a requirement to its implementation and to its verification? That's traceability. But also something more complex, is the requirement feasible? So not only can it be implemented, but can it be implemented via or with BSH? So do we have the resources for this? This is something that a requirements engineer needs to check. And of course, this is a lot of guesswork, right? So this is something that is very complicated to fulfill with a large language model. Usually, when you test for traceability, you don't have the implementation yet. You don't have the test cases yet. So you cannot really test whether all these traces exist in the very beginning. And feasibility is also something that is very difficult to test from a large language model. So here we have a lot more difficulty, and we are still working on that. But we also have a demo where we at least check already some requirement against at least some of those criteria. So this is now running a quality check, not a syntax check. And you can see here that the requirement, the same example, I think, is, pause it here, is not checking the implementation-free criteria. So the definition of the dbus connector is already kind of suggesting how to implement the requirement, and this is then not fulfilling the implementation-free criteria. All right, and then we come to the last use case that I want to show you today. Of course, now we have checked the requirements against our criteria, against syntax, and against quality, and we suggested improvements. But it would be much easier for the requirements engineer when he's writing the requirement to already get suggested an improved version of the requirement. So can we use what we have now created to take the core of a requirement that an engineer has written and rewrite it so the content stays the same, but it fulfills all of our syntax and quality criteria? And for that, we have basically implemented a loop where the requirement is checked against our syntax and then quality check. The outcome of that check is also put into the prompt to rewrite the requirement, and then we loop it again. So it's a bounded refinement loop where we run through the syntax and quality checks again and again. We also found out that for syntax check, after 5 times, if you still don't have a correct requirement, there's something else wrong with it. So we stop the loop after 5 times for the syntax check. For the quality check, it's even closer. So if you have after 2 or 3 reruns not a correct requirement, something is wrong with it that cannot be fixed. So oftentimes you have, for example, tables in the requirement, or it's completely nonsense. This also exists sometimes. So in that case, the large language model cannot rewrite it into a good requirement. So it's correct that it then fails after a couple of tries. All right, and I also have a demo of this, but this is really quite boring. So we have the same requirement again, and unfortunately, the loop also takes some time, so we need to work on improving that. But after roughly 15 seconds or so, I will jump forward a bit. You'll then just have as an output the correct requirement. All right, so these are 3 demo use cases. Of course, I've showed you this now in just a web front end, but this is not how requirements engineers are creating or reviewing requirements. We have our own tool for that. It's a Siemens tool. It's called Polarion. I will not comment on the quality of Polarion. It is implemented, so the UI is implemented in Apache Velocity, so that's Java and JavaScript basically. So of course, our use cases need to live in the authoring tool that is used by the requirements engineers. So at the moment, we are integrating them into the front end. In terms of data, there's also things to consider. So of course, if we have some use cases where we, for example, search for similar requirements, that generates a lot of traffic in Polarion, a lot of access to the database, and we don't want to slow down the system. So we need to mirror basically the Polarion database. We need to vectorize it and ideally create an MCP server to access the database, access the functions of Polarion. And then there's also the question of data recency. So is it enough to maybe have daily updates of the data, or do we need real-time data? So do we have workflows where someone writes a requirement, it needs to be immediately then checked against or used in some kind of different large language model use case? So this is something we're still figuring out. And of course, there's the topic of data security. So there's a need-to-know principle here. So usually an engineer should only have access to the requirements of the project that he's working on, which is not really helpful for a lot of large language model use cases. And all of this that we have developed runs on our AI backend platform. And I will hand over to Saif now, who will explain a bit more about how this platform works.
Thank you. Thank you, Philip. All right. Thank you, everyone. I'm going to zoom out a little bit and hopefully bring some insights in where this kind of use cases happen. I myself, I'm Saif Ellafi. I work also at BSH with Philip in a different area where we work more on this AI platform. And where does this kind of use cases happen and take place? To zoom out a little bit, to put it a bit ourselves in the perspective, what do we do? Like Philip mentioned 3 or 4 use cases on requirements engineering, but what would we do as a company when we have 400 of these use cases? And I would like to see, like, or gladly after the talk, discuss with you and like figure out how how large companies also and non-IT companies figure this out, right? How do we adapt to a battery of use cases who are hungry for productivity boosts, integrate AI because the competition is already on the race, and we have this feeling of racing towards the AI use cases. So I would like to talk about that. It's like, hey, how could we enable an organization to get this done? Not without problems, of course, so I'm going to share a bit of insight. So BSH is huge, it's large. There are multiple stakeholders, and we are like an AI platform globally. That does not mean that the integration is fully at this scale, but it marks from the platform in which direction we want to go organizationally. And platform owners, I'm not sure if there are any here, would need to think how we standardize the use cases. What happens when we have digital platform services? What we have when we have appliances department that builds these products, the requirements for these products? What when there is consumer people who are analyzing consumer feedback, the demands of the new users? Hey, when do I get AI in my appliance? And how do we get that done? So from platform perspective, a few years ago, we would think in a cloud, some data engineering pipeline, some data connectors, right? Machine learning operations, maybe a few ML ops are out there. It's like, hey, how do we deploy 4 or 5 models, maybe 10 to production? But now it's getting a bit faster. So, of course, we try to set up a governance model. This is the perspective, right? How do we do with all of these stakeholders who need to get out there quickly? How do we govern them? How do we separate how much each of them costs? How do we evaluate which ones are worth the value? I bet many of you are exploring amazing LLM-based ideas or Gen AI-based ideas, and then the boss comes and say, hey, how much revenue will we increase with this use case? And say, I don't know, it's just cool, and everybody else has it, right? So there is a lot of that push, and that's hard for organizations to measure. And we are being asked from IT head, please take those that are, or that generate profit, right, in the end. Of course, technology and competition matter, so sometimes if a competition product has it, we have to have it as well. So back into the tetchy part. How do we prepare for this battery of things very quickly? We have to standardize, and standardizing is hard. I think, 3 months ago, ChatGPT was king, then Gemini 2.5 kicked butt, and then now Cloud Code, and it's like, hey guys, how do you not have Cloud Code already? And we are slow already because we took 2 weeks to figure out how we integrate cloud. So it's different, right? And the use cases need a lot of things because yes, POCs and is fast. Everybody knows that we can prototype something with vibe coding. But when those use cases are proved and business says, hey, we want it, what if 400 use cases did the POC differently? Once used, Lovely, I think. The other used Vercel, or each department used their own stack, and now we have to release those on production, go through compliance, check data protection. What if we say the wrong things through the use cases? So that's what I'm trying to share, what from platform we have to do. So it's a huge undertaking. One of the use cases is like, of course, technicians' chatbots, right? We have to be precise. We cannot tell a customer of a BSH appliance, press the red button, and then the user goes and says, hey, there's no red button here. And we cannot afford that kind of mistakes when we are releasing products out there, right? So we have to be specific to the serial number, to the region of that device, to the user manual's content of that appliance. So RAGs become a thing. To tell the story a little bit, I'm going through the platform through an example, which is RAGs, right? Like Philip also mentioned, requirements engineering, it's not general. Yes, it is, like LLMs are very knowledgeable, but we need to tell it the information we have at our specific development. So RAGs are a thing, and that's one of the first things we added in the AI platform. We have to have a single way to do RAGs. You might know there is semantic chunking. Maybe you have, if you're lucky and you have good data quality, you can do some graph-based knowledge base, but we have to standardize that, because the more we standardize, the third time we do a RAG-based application, we should not take as long as we took for the first two. And this is where AI platforms matter. So when the second use case comes and say, hey, we want to support our technicians to better repair products very quickly, we cannot tell them, oh, let's do a RAG again, right? So we try to take from the platform common features. And what are common features? I guess a chatbot, a RAG, answering with images, pulling BSH. What if each of the departments spent hundreds, I don't know, 10,000 euros in indexing with, I don't know, document intelligence, you might know. Somebody else uses some self-hosted CPU, GPU-based OCR, and then like we cannot do that, right? All of the use cases would be automatically unprofitable. So how do we do that? It's like, let's have a RAG. And this is not rocket science. It's more, what matters is that we say, look, let's do RAG this way. And there will be this person who says, your RAG sucks, or it's too slow, or quality is not good. But you know, sometimes that we are reusing the same architecture profits more and outweighs the maybe poorer performance because we are not using the latest fancy, I don't know what's the latest fanciest RAG right now, RAGflow or knowledge base from Amazon or Azure AI or whichever. So, and then we need to think of things like, where's the data stored? Do we want to copy all of our data somewhere else because they have the coolest, fanciest RAG solution? Like if there are data engineers, I guess you're already crying if somebody comes and say, hey, GCP is the new thing. We have to move all of our data over there. So not fun. So that's the thing. And the RAG comes along with many components. We need traceability because we need to have accountability for what the LLM decides to say. If a user comes with legal problems and say, hey, your LLM told me to do this, and I did this, and my appliance burned, right? It's a thing, and we have to have traces over it. There are some examples here in this diagram. I think Langfuse is over there. There's Langsmith. Again, it doesn't matter. What matters is that there is a decision in the platform design. There's also analytics, Power BI, that also like, hey, the managers want to know how much we are spending because the tokens, yes, they are individually cheap, so to say. We all know that. But if we put, I don't know, 12 parallel cloud Opus agents to run 24 hours 7, I'm not sure if it's so cheap anymore. Ingestion. Data matters in all AI use cases because, yes, everybody can use ChatGPT, but again, as product builders and developers, we want to be precise and specific. So ingestion matters, the data of the quality. So I think, personal opinion, I'm not reading the future, but data engineers have some work to do in getting that data AI ready. It's a bit of a buzzword, AI ready, but we think it exists, right? Because if you plug in an agent to your SAP BW system and expect that chatbot to quickly query something, then forget it, right? It's gonna take a few days. So there is a concept of fast data, so the AIs can make use of them, or agents, or whatever, tools. AI LLM access also is behind every platform. Hey, can I get ChatGPT? Hey, ChatGPT 5.3 codex is out. Can we have it yesterday? Now I want to move. How do we stay flexible? I think there are solutions like Light LLM. You might know. If not, I really recommend it. You don't want to give an API key for each model to each person in a 60,000 employees company. I don't recommend that. We tried it. Don't do it. So give one key and make sure this key is rerouting to the proper LLMs. There are also providers. The problem of providers is that you don't know what they do with your data. So I'm not going to get into that, but this is a corporate work. So imagine right now I'm going all through this platform build up, right? But we have these 400 stakeholders wanting to start something yesterday because if we start tomorrow, it's already too late. So I would really like to figure out how do we see that from platform perspective. We will always be slow. So how do we get fast and slow and deliver those use cases when we don't know what happens with the data we inject in the context? So super interesting topic. Observability you need because you cannot go out to production if you don't know what your LLMs are doing. There are tools like Langfuse. Measuring LLM's quality is another challenge, and this is why I still think data engineers will also be busy here, because you will have to set up very good, and data scientists as well, very good ground truth baselines for your products. So you can have automated metrics that prevent risky or undesired outcomes from your LLMs. And therefore, you can also improve your RAG systems, your retrieval quality, and so on. So yes, again, it's all a whole part. What I'm going through when I go through these slides is to share, hey, what are the components, the basic components that we know that regardless of the use case, we will need. Of course, we put Langfuse here, and then yesterday somebody came to me and say, you guys are so outdated. Everybody's using PromptFoo now. And say, yes, but we have to, pay for those tools if we want to go prod. So again, reusability pays off more than being the coolest in our opinion. Guardrails will not go deep, but you don't want the LLMs to talk things you don't want it to talk about. Yeah, the classic example is what if a user uses an appliance or asks questions about a competitor's device and we say garbage. That could be problematic for legal and commercial. Of course, if you have an agent that is dynamically retrieving user information from a database, you don't want that agent accidentally to provide a credit card number to that person, right? Hey, here you have purchased your next oven. So those kind of things we have to be careful about. So to come up to a conclusion, I hope this is insightful. We think that a central strategy in a platform matters. Doesn't have to be unique, doesn't have to be cool. This is just an example one. But it's very important and useful that a central AI platform determines what is this standard stack, because then you avoid that each department is building things in their own way, because translating all of those POCs into the productive stack is going to be a lot of work if it's not already beginning there in the first place. So with that said, I would love to know how does your GenAI platform looks like? What did you do with ML ops and data science? Yes, and how does your environment for development looks like? So thanks.